Let's look at the difference between a traditionally built web application using modern web development approaches and the HAX way. In a normal build routine of the process of getting a website from the developers working on that website out the door for you and I to see, there's a bit of magic involved. That magic of modern development is known as Webpack or Rollup. And it's a piece of technology that takes distributed assets across hundreds of projects and combines them into small bundles. This approach, known as bundling, is how we see modern websites and web assets. Now, when teams are developing these new projects, they're typically drawing assets from a technology called NPM, or Node Package Manager. This allows other developers on other teams, let's say at Google via Material, or Twitter via Bootstrap, or the Vue team, or React with Facebook, and Angular at Google again, or Tailwind, to use their code development approaches to ship their libraries in a format that our teams can ingest and use with reproducibility, so that version 2.1.2 is always version 2.1.2. And that's awesome because we can build amazing things by leveraging the work of others through open source and open technology. In fact, we could also use our own code that we publish to NPM so that other teams could repurpose these things. In this case shown, Project Team 1 might have some internal application that the code shouldn't really go out in the wild. Maybe that lives on our internal GitLab instance. But they're still able to leverage assets from NPM and the vast variety of JavaScript frameworks and CSS design libraries for design consistency and really high performant application and developer experiences. Whereas Project Team 2 or N+1 with specialized staffing is able to leverage and generate their own assets that they publish publicly to GitHub while reusing all of the assets of NPM. All of that code then comes down and gets passed through a bundler, which outputs very small JavaScript, CSS, and image files. This is a process known as tree shaking, in which we attempt to take lots of code from lots of sources and bundle it up in such a way that it serves our end users with fast content page loads. So for example, if this process were to happen and we end up getting COVID app or the PSU website or N+1 web property, imagine this is going on for every web property in some capacity, whether that's the design assets or a full-on application stack. We are getting maximum reuse of other people's work as far as stored assets at specific versions. Then each of these is going to be powered by some type of content delivery network, whether that's Vercel, Netlify, Cloudflare, AWS, something that is taking these static assets and shipping them so that our web servers never go down and are served quickly by a large population. However, what ends up also happening is we have bespoke units generating small standalone websites. These websites sometimes look like university properties. They sometimes leverage these sources, although a lot of specialized knowledge and training is required. And as a result, our end users end up with experiences that are a mix. Some of them do look very brand standard. They deliver very quickly. They have high SEO scores and show up in search results highly. And others, just as a result of the process of leveraging other people's work, are able to do some mix of good and bad. They're able to use sources of truth as far as things like Bootstrap for design libraries, but they're not able to deploy them and get them out to users as quickly as possible. It might take a very long time to deliver a custom bespoke website as a result. In the end user or potential student, parent, whoever it is, ends up getting a mixed experience, which leaves them with a mixed impression of what to expect when coming here. So let's HAX the web for a bit. HAX the web ships in a methodology known as unbundled. This is an approach where we are taking assets, compiling them, but they're still standalone assets. We're not building entire applications. In this configuration, the core team working on our own repo puts assets out into the wild. These assets go to GitHub, and then they're published as standalone components on NPM. something that could be done in our original configuration. We see that there's teams working in GitHub, publishing code out to NPM for reuse. In this setup, the HAX team largely works within something called a monorepo, which allows us to work on a singular product. However, it's able to be consumed by other developers as hundreds of different products. This is something you see in design libraries and operating systems more typically. Now, when we're working and building these things, we're working in these scoped individual components that meet individual needs. Then we run through a very simple build routine that effectively generates this type of a file. It's a registry file in which the name of the element points to the location of the JavaScript that powers that element. These assets are then pushed out to a CDN-based repo. That repo is picked up and thrown out to AWS, and we have our assets on a CDN. Now, when it comes to actually implementing and leveraging these assets, which we'll see examples of in a second, the end user developer side, as far as person building the site or site builder, administering the content management system, does not need to have specialized knowledge in order to build a rapid website that's extremely fast and meeting the brand standards. There is a 2-line copy and paste script in the HAX universe called Magic Script. The Magic Script is able to effectively bundle up and ship to a CDN this type of data feedback loop so that any asset published to the repo is registered as far as where that lives and then tells any property we have how to load that one individual file. Now, you still do end up with CMS platforms, you have some homegrown solutions, you have your top level domains and your custom applications. However, each subsequent page load is actually making the additional properties faster. This is a result of the unbundled nature of what we're building. Remember, before a process is run in which all of this work is used and built upon by developers, smashed into tiny assets, and then served individually to each application. Because we're not smashing these things down to the point that they're unrecognizable, we're compressing the assets in place. It allows them to hydrate all of these properties. For example, if you load an icon on the Penn State website or the top header, when you go to the next website also using that icon or header, you aren't downloading that asset anymore. It comes for free. This means someone could go to a self-made website leveraging the Magic Script to increase efficiency of how that site is built and actually optimize a homegrown property that's optimizing a hosted WordPress solution, that's optimizing anything we can get onto a vendor via that 2 lines of JavaScript. This ends up allowing us to meet some of our core pillars of the institution as a result. When it comes to accessibility, if we're baking accessibility into our web components, we can make sure that those issues are resolved ahead of time with greater accuracy. But if an error was to slip out in the wild, we can also fix it retroactively. We can continue to work towards being platform agnostic because web components work below these systems and in all of those systems. This allows us to sustain current efforts while slowly walking out the door towards a world where we have singular platforms and design criteria. It's also simple. Anyone can copy and paste these 2 lines of script. We have control over the repo and the source. We can set up governance as far as what elements are dictated there, who has access to them, all of those types of things. But it's very simple to implement as a developer. This also helps us meet the goals of one PSU. This allows courseware and web properties to look more like the singular vision of Penn State as opposed to all of the different versions and units and academic homes that we have in service of that mission. Long term, this also reduces training costs as we move towards a platform agnostic approach. This also allows us to serve a world and state audience more effectively. Because these assets can be leveraged in OER, and then those assets can turn around and build the brand, and then those assets can turn around and build a learning management system, and then those assets can turn around and build a front-facing club, organization, or website, we're able to build fast, small, agile properties with less and less technical knowledge required to do so. This helps us meet a world audience with assets faster, as each asset actually enhances the experience of the next. This is more sustainable than traditional approaches, as less code means faster code. This also is sustainable as far as the environment, because when there's less code sent over the wire, that's less burning of fossil fuels to keep servers online, less connecting to content delivery networks, and more time engaging with a property local on your device. It also makes it more sustainable when we're tracing and trying to scale and maintain code over time. There's a lot of back tracing that can happen as far as singular file points to single asset. And efficiency. There's less time to develop. We need less specialized knowledge. There's less specialized systems and contracts with vendors to lock us into certain formats on the web. So this is long-term sustainable, and it's also something that can reinvigorate a workforce in need of ways of working that are more agile than has traditionally been the case in a CMS-based universe. So, for example, if I went to and developers built a COVID testing application, all of these assets in this page are compiled in some way. We can see this via these large hash values .css, large hash values .javascript over the network. So it increased the efficiency of building this, but not of actually receiving the material. It meets a lot of brand standards as a result of drawing from a singular bucket, and that's awesome. So the Penn State website also would go through this, and then all of the Commonwealth campuses. And so we've got brand consistency going on and a huge movement towards brand consistency so that we have a singular experience from a design perspective. However, these websites take a long time to build, and that brand then needs maintained. The unbundled content delivery network approach would solve a lot of the issues with time to build as well as long-term maintenance, because they're coming from a secondary source. That would help bring all of our properties into alignment as far as meeting the brand exactly as dictated, no matter where they are. So when you go to the IST website, you would effectively make the World Campus website faster, which would make the arts and design website faster, which would make sciences faster, which would make the HR website faster. In a lot of these properties, this top bar and these flyouts are identical in code structure, yet they needed to be downloaded over and over again every single time I went to these. Now, contrast that with the HAX approach. This is the Office of Digital Learning's website. If I were to right-click and inspect, they have taken a more traditional approach as far as getting these assets from NPM, from a shared bucket, and compiling them to work on this website. So we still have those original approaches to allow for bespoke, customized development. However, when we get into the weeds of in our course materials, let's say it's a video in this case, that video player can be fed from a content delivery network so that we have a highly accessible video player that the entire university and beyond, for that matter, can leverage from a single 2-line script that's easy for anyone to understand. This video player then can be maintained after the fact. When we're talking about simple interactions as far as accessibility with collapses and field sets, it's one thing. But when we're talking about the complexities of a moving video player that has to track where we are in its progression with lots of different settings, it is possible that there's something that needs to be updated for accessibility after the fact. This approach accommodates that. The CDN can feed and make other unrelated properties faster. In this case, the hackstheweb.org website loads lightning fast because of this approach, even on a subsequent reload, because it's using the content delivery network that we've been discussing. Here you can see we even tell people how to wire up to the content delivery network to power their universe. Or the hax.psu.edu website that's built using assets that are off of that content delivery network, leveraged over and over again. In this case, even something as simple as a future terminal text element made originally for a course, an online course to discuss topics of how to build web components. This was 3 years old, and yet we're able to still leverage and build on top of those resources going forward. Or if we want to use other content management systems and put this in place, this is a version of a different CMS that has our video player loaded into it via that 2-line magic script. This gives us a unified experience and the ability to progressively enhance older properties. Or if it's more modern online courses, or if it's courses across colleges in this case, each subsequent page will load faster than the previous one as a result of using these same assets to power them. Or in this case, the university library has used these assets mixed in with their own to solve an instructional objective. In this case, they've leveraged the CDN as far as delivery of the large scaffolding of the website to make it load faster. And then within that, this custom asset, which allows for reading historical plays and putting them in context. So no matter where these assets are coming from, the magic script is able to feed them all back from the one singular content delivery network. This script is open source and can be repurposed. We could have multiple versions of the script. Some scripts could potentially be Penn State internal, and they only feed out the university brand as dictated by the branding office. Or if we had some instructional assets, they could go out on a different content delivery network. Or we could have a hybrid where we have an additional third one that has assets that we allow out to the whole world as part of our OER and open efforts.